I'm told that PA and PC are tangents to the circle at A and C. So at that point A and C, I've got tangents, and they come from the same point. So that's really significant because now I've got the theorem, tangents from the same point. So I'm going to go over the tangents, and then I'm going to mark out what is significant about the fact that you have tangents from the same point. So it's that these base angles that are made, because there is a line AC, right? These base angles are now equal to each other. So I've marked them out with a single purple bar. Okay, so what else are they each equal to? Well, tan chord is significant here because in tan chord I've got A4 plus 3. They make an angle with AC, and AC subtends D1 and 2 together at the circumference. I've got a couple of other tan chords going on as well. I've got the fact that A4 would equal D1, which means A3 would equal D2. There's a couple of other tan chords going on, so I'm just going to make a note here and look for more tan chords later if necessary, because otherwise my diagram is going to get unpleasantly full and I might lose track of where I'm going. And the reason I know to do that is I'm glancing at the questions, but I'm not letting them define everything I do with the information. The next thing I'm told is that AD is parallel to PC and PD cuts the circle at B. Right, that's to alert me to something, and if you look a bit further down, it's this one here. It's the B1 equals B3. I've got to do something with that and be aware of what's happening, and that's not a theorem. I'm going to have to use several different things to help me understand what's going on there. But first of all, I'm going to highlight the parallel lines. At this point, I'm glancing down because, again, I've got so many things with parallel lines and I can just see angles everywhere. So I'm now looking at the question and I'm thinking, okay, AC bisects PAD. What is that? Okay, to P to A to D, I need to go required to prove that angle A3 plus angle A4, that those equal angle A2. Okay, so that's actually what I've got to do, because bisect angle means I've got to prove two angles are equal to each other. If it was bisect a chord, I'd have to prove that two sections of the chord are equal to each other, but this one's an angle. So let me just see now. I need to see with A4 and 3 together, I've already got a few other things that they're equal to. So I want to know, does the parallel lines, do those guys give me a bit more? And they do. They make this Z here. They go there with the C1 and C2, which I already know is equal to A4 and 3, and they make an A2. So those are equal to each other. Okay, and yes, there's other things I can add with the parallel lines, but I must also remember that PA is not parallel to CD. And if you've got to turn your paper to help you see the Z's or the N's or whatever you call them for alternate angles, then do that, because it's very important to not see stuff that's actually not there and not to project it onto a diagram, because it would be easy to work with if it was the case. So starting off with question A there, I need to just trace my steps. So I got that A3 plus A4, I got that they equaled, let's go the shortest route here. They were the same as C1 plus C2. And the reason for that was tangents from the same point. And then I got from the parallel lines, I got that C1 plus C2, that was equal to A2. And that was because of my alternate angles. Therefore, my A3 plus A4 equals A2. And therefore I've got the fact that this angle PAD is bisected by AC. So because it was AC that bisects PAD, that's how I knew it was A3 and 4 that had to equal A2, because they told me the line that's supposed to be bisected, which is that one there. The next thing I need to prove is that B1 equals B3. And I've marked out nothing so far. So let's go back and see what else needs to be marked out. Okay, so what else is B1 equal to? Well, it's in a really nice cyclic quad, right? And it links from the previous question because B1 is actually the same as A1 because of angles in the same segment. So I'm going to mark them out like that. What else could B1 be equal to? Well, if I can't see anything just yet, let's see if I can find out what B3 is equal to. So B3 is an exterior angle of a cyclic quad. B3 would be equal to the interior opposite. It is the exterior angle of the cyclic quad because it is the side of the cyclic quad BC. It's extending that line. So B3 equals D1 and 2. Okay, so we've actually already proven it. So B1 equals A2 because of angles in the same segment. A2 equaled A3 plus A4. We have proven that. Okay. But then that A3 plus A4 equaled D1 plus D2. Okay. And that was because of tan chord. Therefore, let's just look at what we've traced our steps through. We said B1 is A2, A2 is the other two A's, and then those A's are the D's. So actually, it's that B1 equals D1 plus D2. Okay, then I'm going to move on and I'm going to talk about B3, equaling them as well because of exterior angle of a cyclic quad. Therefore, they're equal to each other. So therefore, B1 equals B3. The next thing is to prove that APC equals ABD. And those I need to translate for myself into what's available in the diagram. So A to P to C. Okay, so the first one is actually P1. So I'm required to prove that P1 plus P2, that's APC, equals A to B to D. So that is B2. I haven't just worked with that, but there's going to be information available on the diagram. This time I haven't marked everything out in advance, and the reason is it felt like I was going to confuse myself. So it's not wrong if you went and marked everything out, but it's just going to be difficult. And here I'm going to mark it out as I go. And remember, I made that note for myself that said, okay, but there might be more tangents. Okay, so maybe I'll be looking at that. Also, there's probably more stuff to do with the parallel lines as well, and there will be for this question. Okay, so P1 plus P2, are they going to give us anything? What is P1 plus P2 the same as? We'll have a look. We've got the parallel lines, and P1 and P2 are in them. P1 and P2 together, I'm going to make them a double bar. So where are they equal to something to do with the parallel lines? Do you see there that A1 is corresponding? So that's helpful. I want to now see about A1, and here's where my more tan chords are going to come in. A1 is the same as the angle subtended by AD. And guess what that is? That is B2. So I'm going to say P1 plus P2 equals A1. My reason? Corresponding angles. And then A1 equals B2 because of tan chord. Therefore, they're equal to each other. So P1 and P2 equal B2. And then I've got to just translate that back to what the question was. Therefore, APC equals A, B, D.